So in this video, I'm going to explain about the instruction LDAX, load accumulator indirect. So this instruction comes under the data transfer instruction set. So here first of all, we'll see their opcode. Opcode for this instruction is LDAX and their operand will be as like BC register pair or DE register pair. So here we are not using HL register pair as operand because HL register pair is already used as a memory register. So that is the reason we are not using HL register pair as operand. We are using only BC register pair or D register pair for the instruction of LDAX. So now first of all we'll see their functionality, then we'll find out the rest of the part. So here for example, let's say this instruction is written here as a LDAXB. So B is here having the function of BC register pair. If you write it here as a LDAXD, it means we are taking here as a DE register pair. So what it will perform, that LD means it is having the purpose of load. This LD means load, A means accumulator, and this X means register pair. So as a register pair, either we can use as a BC register pair or D register pair, and only the high order letter we are assigning as a operand, either B or as a D. Now, what is the function of this? Whatever is the content of this register pair, that will be treated as a address of that memory location from where the data will be copying into the accumulator. So LD means load. Load, which one have to load? Accumulator have to load. From where have to load? From the memory whose address is pointed by this register pair, either BC register pair or DE register pair. So let's say for example, before execution of this instruction as a LDAXB, if this instruction, like if the BC register pair is having the content here as like this is B, this is C, so this is 20H, this is 50H. So in the memory, as like let's see, this is our memories. So in this one, if you see that at this point it is having the memory address as a 2050H, and at this address if some content is written as a 97H. So whenever we will execute this instruction as a LDAXB, the content of this BC register pair is going to point the memory, and this is copying here the content from this memory location. So memory location is having the content of 97H. So after execution of LDAXB, the content of accumulator will have it here as a 97H. Before of the execution of this LDAXB, whatever is the content of accumulator, now it is going to overwrite with the values of 97H. So if you check the content of accumulator after execution of this LDAXB, you will find out that that will be 97H. So here, why it is called indirect? Because the address of the data which we need to copy from the memory to the accumulator is not mentioned directly in this instruction. It is taken by this register pair content either as a BC register pair or DE register pair. So the content of BC register pair or DE register pair will pointing the memory, and from that memory location, what is the content over there? In this example, I had taken 97H. So that will be copying into the accumulator. So after execution of this instruction, if you check it, the content of accumulator, it will come 97H. And here, it will not affect the content of either B or C or this address location, whatever it is having 97H. So these all three content is not going to change. What is going to change? The content of accumulator now after execution of this instruction will be changing by the values of this 97H. So by this way, it is the functionality of this instruction. Now we need to find out their size. So if you'll see that in this instruction, we are using only English alphabet. So due to that reason, we can assign that size of this instruction will have here as a 1 byte. Now machine cycle. So how many machine cycle it is required to complete the execution of this instruction? So first of all, by default for any instruction, it is having their opcode fetch. So LDAX whatever is having their code, so that code will be fetched first from the memory. So that first operation will be opcode fetch. First operation will be opcode fetch, that is required here for T state for this instruction by default. After this, after opcode fetching, processor is knowing that we need to access the data from the memory to the processor, because this 97H is previously stored into the memory and now it is coming to the accumulator which is residing in the processor. So here we are reading that data is coming from memory to processor. So that process is called, that machine cycle is called as a memory read. So the second operation will have here as a memory read. So for this memory read, by default, as per the previous videos I already had explained, for the memory read it is required 3 T state. So total it will take here as a 7 T state. So here as a machine cycle we can say it here as a 2 machine cycle it is required. One is called opcode fetch and another one is called as a memory read, and total number of T states required for the execution of this instruction is called here as a 7 T state. So by this way we learn about this instruction as a LDAX. I hope you understand this instruction in the better way.